Is on mobile performance tips and tricks. And before we get started, I want to take a quick survey to see what kind of devices people are using. How many folks are using an Android device? Okay, wow, that's a lot. iOS device? Who's still unlucky enough to have a BlackBerry? Anybody? Nope, not a single person has a BlackBerry. Wow, Windows Phone? Anybody? Windows Phone? One. Okay. Which phone do you have, sir? Which one? Is that Windows 7 one or Windows 8? Do you like the phone? How about the operating system? Okay, that's great. I actually really like Windows Phone 8. Unfortunately, it's made by Microsoft, so it'll probably never get off the ground. The operating system is quite pleasant. So I carry a bunch of different devices because we specialize in building stuff. A single product actually called Triplingo, which is a foreign language learning and culture tool for people who speak English. So for example, we have English to Hindi for business people who come to India, for example. Okay, we don't have Telugu yet, but we're working on that. So what we do is we build mobile apps, and so we're heavily invested in the mobile space. And what I'm going to do today is talk about these topics. We're going to talk about why mobile performance matters. We'll go through that quickly. We'll look at the landscape. We'll talk about device performance. Network performance, so that you understand what it takes to build a performant mobile app. And then we'll look at some specific techniques. Okay? If you have any questions while we're going through this, please shout them out or raise your hand. Questions are welcome at any time. All right, so let's look at the mobile landscape quickly. So one thing that I tell folks, especially folks who are new to mobile development, is that you can't apply the same techniques that you have for doing just general web performance enhancements on the mobile space. The mobile space is quite unique and has a lot of different set of limitations that you need to understand to be able to build performant mobile applications, right? And I'm not going to go over the mobile traffic and some of the other quotes here. By now, everybody realizes that mobile is where the UI platform of the future is, right? Everyone uses a mobile phone, as well as using, sorry, I don't know why this is beeping at me, as well as using the web. But mobile is definitely the dominating platform, especially in non-Western world. Okay, so as you know, in terms of e-commerce, Amazon sells over $1 billion worth of goods in a year from a mobile device, which is quite interesting. And one thing that a lot of people don't know is that Google actually made a change recently. So how many people care for the work that they do about search engine optimization? You know what SEO is? Right. SEO is search engine optimization. That means that when you put a website or a mobile website out, the way that it gets ranked is, the art of building that so that it gets higher ranked on a Google search is called search engine optimization. Well, I don't know if you know this, but recently Google made a change that for mobile websites, the amount of time that it takes to load your website actually factors in to the SEO ranking. Right? Did anybody already know this? Right, so this is something that's very new. It happened in the last couple of months, actually. So one way that you can actually get a much better SEO rating right now is because people haven't caught on to this, is if you optimize your mobile website to load very, very fast, you will move up the SEO ranking much faster. Okay, so this is something that Google's doing, and it's causing a lot of angst in the community. But before we start getting to the nuts and bolts of specific programming techniques or other techniques that you can use to get better mobile performance, it's a good idea to talk about the user experience first, right? So if you look at these three screenshots, right, so you can see that this says loading, 28%, and then obviously you have the ubiquitous spinner, and this spinner has nothing on it except for this little status bar. And I love this one, downloading. This might take a while. How long is it going to take, right? Not letting the user know how long something is going to take is absolutely the worst thing that you can do, because the user has no idea. Like, if you look at this, how long do you think this is going to take? You have no idea, right? So this is one of the key things that I zero in on is when you have to have the user wait for something, you always have to let them know. Just give them a rough idea of how long it's going to take. The more precise you can be, obviously, the better. So the other thing that we do in terms of mobile performance in our application, so this is a screenshot of some of the different parts of our application. One of the things that we do quite heavily in our app is we use a lot of animation. So this is a bubble animation that pops up out of somewhere. Okay? And again, this has to do with crafting a user experience with your application. Even if you're building an enterprise application, what's happened is that folks who are your users in the enterprise, they have an Android phone or they have an iPhone, and they use these apps that are out there, like let's say WhatsApp, right, or Facebook or something. And those apps are very well constructed. They spend a lot of time on the user experience with those apps. So even though you're building a business app and you can say, well, I don't really care about the user experience that much, the unfortunate problem with that kind of thinking is that your user expects that because they have all these other great apps which have great user experience. So you do have to worry about that even if you're building an enterprise or business application. Okay? So this is an example of the Path application, and one of the things that they do to enhance the user interface is instead of having a standard menu system, the old version of the app had this little X in the bottom corner, and when you press this, these icons would spin out, and that was basically their menu system. So what they did is they looked at the way that they could present a menu system in a unique and kind of fun way, and this is how they did that. Okay? So in terms of what users demand from mobile performance, users expect the same performance on mobile devices as on the desktop. And actually, this is not quite exactly true. Users actually expect more responsive interactions on a mobile device, on a mobile application, than on the desktop. So the standard figure is that a desktop user browsing your website on their computer, on their PC or Mac or whatever, will wait approximately 7 to 9 seconds before they're like, okay, forget this. This is taking too long. I'm going to go do something else. Does anyone want to guess what that metric is on a mobile phone, on a mobile website? Go ahead. Just shout the answers out. It's fine. Go ahead. 2 seconds. Okay. Obviously, you cheated and you knew the answer. No, it's actually less than 2 seconds, right? So when you think in terms of, what do users demand, it's actually much tighter than what you would expect on a website. Okay. So what happens with this is we call it tune out or dropout rates. In terms of when users are using an app or using a mobile website, how quickly they drop out. And essentially users don't want to wait while they're using their mobile app. Okay, and this can be problematic. All right, so let's talk about hardware for a few minutes. So one of the key challenges with building apps or mobile websites for mobile phones is that the hardware across mobile devices varies greatly. Okay. And compared to a desktop, there's less L1, L2 cache, there's less memory, the CPU is slower, there's all sorts of different things. So essentially the device is much slower than what you have on a desktop. Okay? So and that kind of makes sense. So you can guess, that you're running in a more constrained environment. You already know this, right? But this is some of the reasons why the mobile performance and tuning is a little harder, because the hardware itself is just not there in terms of how fast it could be. The other thing is that mobile operating systems are finally tuned to run on that hardware, and they're meant to run smaller footprint applications. So one thing that a lot of people don't know is that if you're using mobile Safari or if you're using Chrome on an Android device, you typically only have somewhere between a 25K to 100K component cache in the web browser. Does anyone want to guess what the component cache on desktop Chrome or desktop IE or desktop Safari is? Anyone want to take a guess? So I said on mobile Safari, mobile Chrome, it's about 100K or less. What do you think it is on the desktop Chrome or desktop Safari? Yeah, so that's about right. The answer, the response was about 2 megabytes, right? Actually, it could be way bigger than that, but you get the idea. It's not just one order of magnitude, 10 times. It's actually 100 times bigger on the desktop, right? When you're writing HTML, CSS, and JavaScript, you have to bear this in mind that the component cache is very small. And we'll talk more about that in a few minutes. And then obviously, there's limited background app support, and thread and process scheduling is quite dramatically different, especially if you're using Android. The way that they do thread and process scheduling on Android is significantly different than the way the JVM works on the desktop or on the server. Okay? I'm not going to go into too much detail about this, but these are just few things that you need to know so that you understand exactly what's going on. And I talked about browsers already. One of the key challenges with building performant mobile web apps is that the browsers vary greatly as well, right? What does that mean? So say, for example, let's take the easy case, which is iOS. Whenever Apple releases a new version of the iOS operating system, right, 7.1 just came out, for example. Usually what they do is they bundle a new version of Webkit, i.e. mobile Safari, into that operating system. So if your users are on iOS 6 or 6.1 or 7.0 or 7.01 or 7.1 or 7.11, which just came out, all those different operating systems have a slightly different version of the web browser, right? And don't even get me started on Android, right? How many people have to build stuff for Android 2.3? Anybody building Android apps? No? Okay. So do you have to build all the way down to Android 2.3? Well, if you do, they have a totally different web browser than what comes in the newer versions of Android. It's not even Chrome. It doesn't have V8, for example, the JavaScript engine. So there are a lot of differences there that you have to accommodate for. All right, let's talk about the network for a few minutes. So this is a chart of network performance, and this is a slightly old chart, but I'll zoom in here so you can see this a little bit better. Okay, and this is in the US. Unfortunately, I wasn't able to find reliable figures for the different mobile carriers in India in terms of speed and reliability. But let's look at some of these numbers really quickly. Right? We have Verizon, Sprint, and AT&T across the top. And again, this is mobile network throughput and performance. So if we look at these numbers, so you can see that, and this is over a 2G network, not 3G. I'm sorry. This is a 3G network, not 4G network. So if you look at these numbers, you can see the download speeds are actually not bad, right? We get, it looks like we bottom out at around 400 kbps, or about half a megabit, okay? And you can see the upload speeds aren't too bad. But then you look at this last line, and you can see reliability here. What reliability means is that the user was able to sustain a data connection from their device to the network for 60 seconds without it going down so that it was unusable or dropping altogether, right? But if you look at some of these reliability numbers, they're actually not that great. Okay? And this is a slightly old chart, so it probably has gotten better since then. But if I zoom back out, you can see that if you live in Orlando, Florida, right, and you're on AT&T, your reliability number is actually pretty bad, right? And as a user, obviously that's frustrating, but as a software developer, this is something you have to accommodate for. Right, so what do? If you have to have the user download something and for some reason the network connection gets broken, what is one way that you can mitigate that? Having a resumable download. Instead of having the user start all the way again in downloading a game pack or a language pack like what we do, you have the user just resume from that point where the network connection was broken so they don't have to start the entire download over. Okay? Let's look at the next chart really quickly. All right, well, before we get to that, one thing I want to go ahead and point out is that, typically speaking, the raw network bandwidth that is available on a mobile device is actually not that bad. Okay, it's actually pretty good in most cases. Those numbers were for 3G networks. I'll show you a slide in just a second for 4G networks. But the real problem is that the latency, i.e. the round-trip ping time, the network latency is the real killer when you're building applications for mobile devices in terms of the network. Okay, so let's look at this really quickly. If we look at this, and this is for a 4G network. 3G networks have a lower round-trip ping time. Okay, but if we look at this really quickly, you'll see that on a 4G network on Verizon, T-Mobile, AT&T, and Sprint, these are the 4 major carriers in the US, the download speeds are actually pretty good. Right? We're getting over 2 megabits a second across all of them, and even the upload speeds are pretty good, right? It looks like we bottom out at maybe 1 megabit upload speed. But then if you look at the last line right here, latency in milliseconds, we have somewhere in the neighborhood of 150 to 200 millisecond latency, okay? So does anyone want to guess, if I were to go on my laptop right now and do a ping to Google, how many milliseconds would it take for my computer to ping Google and come back? What do you think? Any guesses? Sorry? 400 milliseconds. How many? 400? 400 milliseconds. No. It's much less than that. So if I were to ping Google from my laptop, the round-trip ping time, at least on a wireless network, would be in the range of about 30 to 50 milliseconds. When I'm at my desk in Atlanta and I plug my Ethernet jack in, my ping time, because we have fiber in my office, to Google and back is under 5 milliseconds, right? So you compare those numbers, 5 to 50 milliseconds for a desktop user over Wi-Fi to somebody using a network in the 200 millisecond range, and you can see that this becomes a problem. And we'll see specifically why this is a problem in a few minutes. Okay? I'm not going to go into this chart, but this basically shows some of the download speeds. Again, download speeds are part of the problem, right? Or sorry, are not the problem. Right? So one thing that a lot of people make the mistake of when they come from the server side or desktop web programming world to the mobile world is that they don't realize that touch devices are actually quite different in terms of user interaction. We already talked about the user experience a little bit, right? What a lot of people don't know is, say, for example, use a click event for when somebody touches the screen on a mobile device. What the operating system has to do is, because it's a touch device, right? When you have a mouse and you click, it's a physical button, so it's something that the operating system can detect instantaneously. To detect a click on a mouse by the operating system takes under a millisecond because it's a physical button. But on a touchscreen device, people are using their finger. And when someone puts their finger on a device and touches it, the operating system with the capacitive touchscreen has to figure out if that was really a click, or were they starting to swipe, or is it a drag, or is it, there are all the different touch events that they have to accommodate for. So what happens is the operating system has to take a little time to compute that, and hence it takes about 300 milliseconds on iOS to recognize a click event, right? So one of the things that we do in our app is, in the appropriate places, we use touch start instead. So what that means is, as soon as the user touches on the screen, that touch start event is fired. So what we get is we get a sequence: touch start, click, touch end. Okay, so you can listen for all those different events. All right. So again, we have different behavior. There's screen variance. Obviously, there's orientation change. Let's talk about mobile browsers for a few minutes. All right, we talked about this a little bit, so I'm not going to go too much into it. But both iOS and Android use an underlying Webkit browser engine, which is great. Right, so they're essentially using the same stock browser, if you will, at the very bottom. But because of vendor extensions and the versions of the operating system in the browser that are there, it can be something of a mess in trying to narrow down exactly what problems your users may have on that specific platform. The other problem with mobile browsers is that debugging can be harder. Okay, and then of course you have tablet browsers. On a desktop browser, if you're using Google Chrome, you use Chrome Developer Tools. If you're using Firefox, you use Firebug, right? You have all these nice tools built right into the desktop browser to allow you to be able to debug performance issues and other issues in general. But debugging on a mobile browser can be more difficult. So one of the things that I should point out is that recently in iOS 6, actually, the mobile Safari browser allows remote debugging. So that means you can open desktop Safari on your Mac, and from your Macintosh, you can actually connect to a remote iOS device and do basically a remote iOS device running mobile Safari, and you can actually have what you would normally get as a debug session, right? So if your boss says that you can't get a MacBook, right, to work on, you can say, well, I have to have one because I can't debug this web browser without it, right? So, all right. So the other thing I want to talk about is that speed is subjective, right? And again, this goes along with the user experience. Well, what is speed, right? You can obviously measure how long does it take for your website to load, right? When a user touches a submit button, how long does it take to go to the server and come back and display a new page or whatever? But all that is subjective in some ways. I'll give you a perfect example of that. Okay, so this is the Instagram application. Slightly older slide, but this is an Instagram application. So everybody knows what Instagram is, right? Instagram is basically an app that allows you to take pictures and upload them and share them with your friends and blah blah blah. Okay, it's a picture sharing app. But one of the cool things that they do is, if you're normally designing this, what would you do? If you're designing a photo sharing app, you would take a picture, have the user fill in some metadata, and then you would take the metadata and the picture and upload that once the user has done all those steps. What Instagram does is as soon as you take a picture, they start uploading that picture to their server. And then while it's being uploaded, you go and you tag it, you say, this is where I'm at, et cetera, et cetera. And then when you get here, all it has to do is send a little bit of data, that metadata that you said, you tagged people in the picture or whatever it may be, right? So when you get to this step, this is instantaneous because all it has to do is send a little bundle of data instead of sending a half a megabyte or a megabyte picture, okay? All right, so let's talk a little bit about testing. This is where things can get interesting. So what we actually do is we do network simulation to see how an app actually works over a 3G network directly from the simulator, right? So we'll pop open the iOS or Android simulator/emulator, and then we'll use a couple of different tools that allow us to manipulate the network on the computer that we're developing the mobile application for, right? One of those is a program called Charles Proxy. If you're using Mavericks, or I think they introduced this in OS X 10.8, but you can get Charles Proxy for both Windows and for Mac. So if you're building on Windows, they have this tool and several others. If you're building on a Mac and you're building iOS applications, this is a great tool to use, but there's also a network conditioner that's built into the operating system if you don't want to use this. Anyways, what it allows you to do is it allows you to set the bandwidth and, most importantly, the round-trip latency, that ping time that we're talking about. Okay? So you can actually just do a lot of this testing right on the desktop. You don't actually have to put it on the device. Okay? So I'm not going to do this demo because it takes a little while, and we're going to run short on time if we do that. But a couple of other things about testing is that you have to test on a real device at some point. One of the things that we actually do is we test our application. We'll put it on a few Android devices. We'll put it on some iOS devices. And then we will literally test it over Wi-Fi. We'll turn off the Wi-Fi, and we'll test it over 3G to see how long the network interactions are actually taking over a real network. Okay? We don't spend a lot of time doing that, but we will do a test as we're coming up towards the end of a big release to make sure that we haven't missed something. So you do have to test on a real network, a real 3G or 4G network at some point. Okay? And one thing that we found invaluable in terms of testing mobile websites is this thing called MobiTest. Let me show you this really quickly. So what we do, we come to this website. It's called MobiTest, right? The slide decks will be distributed later. And what we're able to do is we're able to put in a website. So for example, I've just put in weather.com right here into the application. I wasn't sure if I'd have a network here, so I ran this test earlier. And what this does is this basically simulates running this website or loading this website from this kind of device. So you can see this was run on iOS 7. It said the average load time was 3.2 seconds. Average page size was 250 kilobytes. Okay? And then if we scroll down, this is what we're really interested in. This is what's called a network waterfall chart. So if we look at this, can you guys in the back read that okay? No? Hey, is everyone in the back asleep? Is that what's going on here? No? All right. So let me try to zoom in a little bit on this. And we'll talk about this in a little bit of detail. All right. So what I did is I entered the URL www.weather.com. And you can see the initial load to that was 381 milliseconds. And because I was loading this from essentially a mobile device, right? This is what it tests. It tests loading from a mobile device. So they have essentially the headers set appropriately, HTTP headers, so that the website on the other side thinks that this is an iPhone, for example. Okay. But anyways, I'm going to run a real test in a minute once I talk through the waterfall chart. So the first thing it did is it took me from www.weather.com to m.weather.com. And what penalty did the user pay for that? So you're building this. Oh, I'm sorry, what was the answer? I'm sorry? Right. So the answer is the user paid a penalty of exactly 211 milliseconds for doing that redirect from www.weather.com to m.weather.com. Okay? So if we look at this, the rest of the waterfall chart for this is actually not too bad. You can see that we have this redirect, and this is when the main site starts loading right here. And then we have a massive waterfall right here where it starts loading some of the main assets. Here's the JavaScript, a bunch of JavaScript files coming in, and then you can see that there's another waterfall starts. I'll need to scroll over a little bit, unfortunately. Okay, but another waterfall starts right about here. Okay, so this is the second stage of the loading right here, and it looks like we have a third waterfall that starts there. And if we look at the third one, this is the ones that are really long. It's about 800 milliseconds, 700 milliseconds, but this green line right here denotes when that page was fully loaded and usable by the user. Okay? So you can see that this is the point at approximately 2.4 milliseconds, right? So if I scroll back up here, you can see that it said that the load time was around 3.3, right? So we're in the neighborhood of when that website was actually usable by the user. But if we look at the last bits here, that took a long time. So this is 700, 500 milliseconds. These waterfalls right here. Oops, wrong button, sorry. These waterfalls right here. Let's go see what those resources actually were. It looks like well, one of them aired out. That's not good. It looks like this is a latitude, longitude, location query. This is some kind of beacon. So this scorecard research is probably, if I had to guess, is probably some kind of analytics or metrics thing. So what you do is you load those last. You load up the page, get the content that the user wants to see, and then in your JavaScript, you go and fire off the analytics. And then you do an ad fill. But at least the user perceives, hey, the website is up and running, I can start using it. And then the ads may fill in, and you send the metrics behind the scenes after the page is already loaded. Okay? So I need a volunteer from the audience to give me their mobile application's website, assuming you have a public website. Does anyone want to volunteer their company's website to see how well it performs? There must be at least one person who's brave enough to do this. No? Sorry, what was that? Oh, that's not your company. You don't work for Amazon, do you? Oh, you do? Okay. So this, unfortunately, this will be, what's going on here? This is going to be a little bit of a loaded test because Amazon.com has a incredibly fine-tuned mobile website, right? So we're going to we can pick these different options here. We could do it on an iPhone or a Nexus or whatever. Let's just run from an iPhone 4, and we'll just run it from their default location. So this will take a second to run, and while it's running, we'll go look at the chart. So you can see it's waiting in the test queue. Hopefully this won't take too long, okay? But again, what we're interested in is, just pull this up really quickly. So what we're interested in, again, is we want to see where the bottlenecks are in the waterfall, right? So this is a screen grab of weather.com, but you can kind of see exactly where the user is having to wait, and these are the resources that are loaded concurrently at one time, okay? So it's the waterfalls that really get you because it's essentially a web browser does stage loading. It'll pull in the HTML first, it'll have to parse it, loads in the JavaScript. After it's parsed the HTML, right, it'll also start loading the CSS. And then as the JavaScripts load and they start doing things, you may load other resources over the network. So let's see if it's still waiting in the test queue. So weather.com actually, and that's what this is a slide for, is actually pretty good. Okay? This is a site that is not good. Okay? So you can't see the numbers here at the top, but there are a few problems with this. Number one, we're loading way too many resources here. Okay, this takes, again, the network is not necessarily the problem. It's just the fact that the web browser on the device has to go load all these resources into memory and then has to render all of them for the user to see, or run the JavaScript, or apply the CSS transforms, or whatever it may be. And that makes the overall user experience very slow. Okay? So let's see if our Amazon.com is loaded yet. Yes, here we go. All right, so here's Amazon.com. And you can see it gave us a screenshot of what it looked like when it loaded. It took, the average load time was 3.92 seconds, which is a little on the slow side. Okay? But let's go look at the waterfall and see what they're doing. Wow. All right, so you can see purposely, instead of putting www.amazon.com, I just put amazon.com here. And look at this. The user paid a 147 millisecond penalty for having to do that redirect to www.amazon.com. Now, the last one was approximately 200 milliseconds on the redirect, right? What's that time on the redirect? That time is basically You go, you get it down, and then it has to do another DNS query, so it has to pull www.amazon.com out of DNS, and then it has to go make that request, right? So anyways, you can see it took a little bit of time to go get that. It loaded a whole bunch of images here. Right off the bat, there's a CSS file here in the middle, okay? And you can see that there's something, images.mobile.min.v1.js here at the bottom, okay? And let's continue going down, and let's see if we see any other interesting stuff here, right? So this is one of the interesting parts here. There's this yellow line right here, right? It probably will be a very long load time on that, right? It says 1.2 seconds, or 1,200 milliseconds. But if we look closely at this, this is actually okay, because what we're doing is we're loading this at the bottom of, we're loading this at the end, once the page is already rendered, essentially, right? And you can see what they've done is this says amazon-adsystem.com. So what they're doing is they're loading the ad, they're filling in the ad at the end after the website is already up and usable by the user, okay? So again, it's giving the user the perception that your site is actually fast. That makes the difference here. Okay, let's see what else they're loading here. They're loading a ton of images here, right? But you can, if we look at the waterfall, unfortunately I can't fit the whole waterfall on this small screen, but you get the idea, right? We're loading a ton of images. We load some JavaScript here, but our overall load time was in the neighborhood of 4 seconds. All right, so let's push forward. And let's talk about some specific techniques and look at some specific things, right? So one of the things that I tell folks is try to avoid doing that redirect, right? So if somebody goes to your website, Amazon.com, and they're coming from a mobile phone, don't redirect them to www.amazon.com. Don't redirect them to mobile.amazon or m.amazon, right? As we saw in the example for both of these, actually, we did a redirect. The user paid a 200 millisecond penalty for that. You might think that's not a lot of time, but again, every 200 milliseconds is actually a substantial amount of time, especially when you factor in that you have a lot of different things to do. Actually, while this is running, let's load up one more really quickly. Does anybody else want to offer their website for criticism or for inspection? Yes, go ahead. 10code.com. Okay, let's try it. Thank you for... What's that? It's just coming up. Sorry, say that again. T? Oh, okay. TN. Like that? Mm-hmm. Oh, okay. I'm sorry. Is that right? Okay. Is that right? Okay. So while I'm talking, we'll let this run. All right. We'll come back to it in a couple of minutes. Let's talk about some specific techniques. All right? So do server-side detection, don't do redirection. You can use the viewport to see how big the screen is, right? It's basically a query type of thing, right? And this is obvious, but use smaller sized images or use less images, okay? And I have a question mark besides progressive enhancement. That can be a little dangerous because if you do progressive enhancement, you still have to load a lot of assets initially and then you scale them down. What you want to do is you don't want to load a lot of assets at all. You just want to load exactly what the user needs for that device. And you know what the user needs because when the HTTP request comes in, it says, this is an iPhone user with this kind of screen or operating system or whatever, right? So you can do that right on the server. And there are libraries that allow you to know in your code, whether you're building in Java, Rails, Grails, or whatever it may be, it allows you to know before you actually send the HTML what kind of device the person is coming from. And again, remember, it's the latency that's really bad. We have plenty of bandwidth, generally speaking. You can send a large JavaScript file if you want, or you can send a large image if you want. Again, you don't want to send those things because it takes processing time to parse it and render all those things. But again, we're more worried about the latency and making multiple requests back to back, right? I.e. the waterfall that I showed previously. That's the bad part of it. All right, let's see if this is loaded yet. Let's see if we're in the test queue. Okay, 17.8 seconds. It's a very nice looking website, I will say that. Okay, and it looks like the average page size is a little on the large side at 2 megabytes. Actually, that's not a little on the large side. That is way too big. Okay. And let's look at your waterfall. Okay? So, sir, your website is obviously not a consumer website like Amazon or something like that, right? Right, okay. So it's for your consulting business or whatever you work for, yeah. So that's okay, right? You don't expect a lot of end users like interacting and, buying, whatever stuff or trying to upload photos, right? But if we look at this, you'll see that here we have the redirect anti-pattern right there, right? And you can see the user actually paid a penalty of approximately 2 seconds for that redirect. Okay, and we're loading a lot of assets here. There's tons of CSS here. There's a lot of, it looks like we have several JavaScripts, right? So this could definitely use some optimization. But again, I'm not going to give this gentleman a hard time because this isn't like a real end user website. This is just a marketing website that you probably have just so you have a website, right? Right. Okay. So, but you get the idea, right? When we look at this in a little bit of detail, there's a single waterfall here at the top because of the redirect, and then we load a ton of assets right here, right? But this is good. We're loading them all simultaneously, and then you can see we do a waterfall right here. Once it looks like the primary JavaScript is loaded, there's a little bit of a waterfall right here where we go load a bunch of other things, and if you look closely, they probably, if we were to go look at their JavaScript, you can see this says googleanalytics.com right here. So they're actually doing the right thing in this case, which is you load and run your analytics at the very end once the page is rendered, and all the useful stuff for the user is there. Okay, you load the analytics, you do your ad fill and other crap like that that the user doesn't care about at the very end. All right, so thank you for volunteering your website. Now you know how to fix it. All right, so let's go on and talk about a few things. So KISS means keep it simple, stupid. Right? It's a common acronym used in the US. So you can target web browsers. You can use HTML5, but you have to be careful that you don't go overboard on tags, CSS, and JavaScript. Okay? And again, the reason for that, there are two reasons for that. The main reason is that it takes time to grab all that down, parse the JavaScript, and then actually render the HTML and CSS and everything together. It takes time to do all that. It also obviously takes time to pull that stuff over the network. Okay, so one thing a lot of people do is they'll combine having multiple CSS and JavaScripts into 1 or 2 or 3 or 4 files instead of a large number of files. Okay, that way you don't have to make multiple round trips to go get that stuff. You can just go get a few files and you have a small number of requests to go get it. Okay? And again, it's all about knowing what you're coding for. You're coding for mobile. So, you guys probably recognize these as common patterns for building just general websites for the desktop, right? Obviously, you do minification, put your JavaScript at the top, you put your CSS JavaScript at the bottom, CSS at the top, right? These are standard techniques that you use for desktop web browser, web app development, but they apply to mobile web development as well. You want to reduce the DNS lookups. You can use gzip compression to reduce the size as well. Right? Browsers support gzip. And again, don't forget, latency is the real issue here. All right? And let's talk about images for a few minutes. Obviously, you want to get rid of that fancy, big 2 megabyte background image that you might use on a desktop site and use a smaller image. Or you can use some of the HTML5 features like CSS3 gradients to give the same kind of effect that a background image might have. Okay? You can also look into CSS spriting, but one thing that we found extraordinarily useful, and this is not just for mobile web, but also for building native mobile applications, is using icon fonts. Okay, and I'll talk more about that in detail. We love icon fonts because it saves us, it enhances the performance of our app dramatically. So one thing that you can do in terms of images so that you don't have to make multiple requests is you can do inlining of images. Okay? What does inlining of images mean? It means that you essentially use what's called a data URI that allows you to embed the image directly inside of an HTML or CSS file. Right? So if we go look at that, this is what it looks like. This is CSS. Right? What we have is we have background URL, data : image, and then we have a UU or base64 encoded translation of an image binary file directly into here. Okay? So for those folks who've used UU encoding or base64 encoding, what would be the problem with this technique? What happens when you take a binary file and you either UU encode or base64 encode it? Yes, that's correct. There's no caching. This is more fundamental than that, actually. Whenever you base64 encode something, let's say you have a 10 kilobyte image file. If you base64 encode it, how big is that? How big is that data now? It's approximately 33. That need to make requests over the network. You can use the app cache, which is something that allows you to store a bunch of stuff inside of the web browser. But this is stuff that is a little bit complicated to use. Some people use local storage for those kinds of things. Okay, let's talk about JavaScript for a few minutes. JavaScript performance on mobile is bad. You can guess why, right? It's because the device is just slower. The engine is great. In fact, if you're using an Android device, the JavaScript engine that you have in Chrome on Android is the same V8 engine that you have on desktop Chrome, right, or in Node.js. So actually the engine is very good, but it's a limited performance device, right? Does anyone want to take a quick guess as to why performance on, just performance in general on a mobile device is much more than it could really be faster? Folks who make the phone and the operating system don't optimize for speed. This is not a trick question, by the way. Exactly. The response was it's all about the battery. If you overclock the CPU, what happens to the battery? It goes down. If you allow a lot of background applications, they chew up CPU, which chews up battery, right? So that's one thing that you have to be very careful that you keep accommodate for. Let's have a quick look at this chart. We'll be winding up in a couple minutes. So this is from a blog post by the folks at Kendo Ui. Right? If you ever need to look at using a mobile web framework, Kendo Ui is one of the best, and they actually just open source a large part of their framework. Right? This is one of my favorites. I think Sencha is good, but Kendo is, for me, is the gold standard in terms of mobile web frameworks. Okay, but let's have a look, and you should go read their blog. They have tons of stuff from Kendo Engineering on doing performant mobile web apps. Okay, but let's have a quick look at this. All right, so what this is total time to complete all their test suites across a bunch of different devices. So if we go look here, this is desktop Internet Explorer, desktop Firefox, desktop Safari, desktop Chrome. You can see they're all in the 200 or so range. And then we have Windows Phone Mango, which is 7.1, I think, and then an iPhone 4. Okay, but you can see the amount of time that it took to run those tests was approximately 20 times slower than the desktop. Okay, and these are very heavily JavaScript and kind of UI update tests. Right. So again, there's a smaller JavaScript cache. You have to optimize the Java like crazy. The main thing is to have less JavaScript if possible. Right? And this is where the framework comes in. If you're using a framework that the framework alone is 25, 30, 40 kilobytes, you've already put yourself, in a bad position. Okay? And a couple of other things really quickly is that it can take up to 100 milliseconds per kilobyte to parse JavaScript. Right? And this is very slow compared to a desktop. All right? And you can dump the framework. Right, you want to, if you're using jQuery, especially if you're using something less than jQuery 2.0, I think, which is modular. If you're using jQuery 1.3, 1.8, 1.9, whatever, you really should look at some of these other frameworks that are out there. These are close to drop-in replacements for jQuery. They're much lighter, but they're not a complete drop-in replacement, but pretty much. Okay, so to give you an example, jQuery 1.8.7 gzipped and minified is approximately 25 kilobytes, and all three of these frameworks, specifically Zepto, minified, and gzipped, is 2.3 kilobytes. So it's 10 times smaller, right? Does anyone want to guess why? And Zepto, XUI, and MicroJS, they target mobile web browsers, specifically iOS and Android, which is WebKit-based web browsers. Does anyone want to guess why jQuery is so much bigger than these other these other frameworks? I'll give you a hint. It's two letters initial that scares the crap out of most web developers, right? It's called IE, Internet Explorer. All right. So anyways, we can talk a little bit more about local storage. We talked about touch events, using different types of things. One interesting thing is that you can keep an open pipe from your application back to the server using WebSockets. Right? This is still something that's in a very early phase, but it can be useful. I've seen people use it successfully. So with that, at the very, very end, I will pause now, or I will stop now, actually. I'll let the other speaker get set up. But while the other speaker is getting, is he here? Oh, there he is in the back. I will let the other speaker get set up, but while he's getting set up, I'll entertain some questions. So any questions I can answer for you quickly? No? All this makes sense?